So I hope I started the stream. Just a second. I did. Okay. Long time no see. In the last episode, in the last chapter, I went over error handlings and the ways we can handle. Just a second. And the way we can handle crashes in our application. So if you look right here, and the file is called the file that we are currently looking at, it's called error handler, right? Yeah, error handling. Where is this file? So let me just remember how I switch between tabs. Okay. So this is how we actually handle errors in as defined in the book. So we create a list of enums, error division by 0, error bad operator, error bad number. What else we have? We have another enumeration of LVAL types, and LVAL types is a custom-made struct that encapsulates the result of checking for the abstract search tree, right? It's here somewhere, yes. Here we are creating a result, and then we are evaluating our result here. So, and the return type of our eval method is the lval, or the Lisp value struct or object in this case. So yeah, that's basically it. I just wanted to go over some questions. How do you give an enum a name? So it most probably asks how to name all of these collections together, so we can use if in case we have multiple enums in our application, we can use these in a more coherent way. And my answer is I have no idea. So I'll just check with my good friend ChatGPT. That's it. How do you give an enum a name in C? For those of you who are joining or just joined or here for the first time, what I basically do is I just learn on my own. I like learning new stuff. I forgot, and I exclusively worked and programmed in C during my uni time. So I just want to remember it. I just want to relearn it, because every form of knowledge is valuable, and learning this, it might be even more valuable because this is the first real programming language. And even now, in God's year of 2024, a lot of stuff is written in C. Okay. The question we asked, how do you give an enum a name? So we specify a name after the enum keyword, and this named enum can later be used to declare variables of the enumeration type. Sorry, my back is a bit stiff. So this is how it works. We have the enum color. We have 3 different values for the color. And this is how we declare it. Enum color, my color red. If my color red, I printf the color is red. I'm just trying to understand something. Can we implicitly derive the value of an enum? Because here we directly assigned a value to the variable. Can we implicitly know that something is of type color, of enum color? For example, here, where the hell are you? Here, this eval result type, which I created here, could I have put, for example, enum errors, and here I use errors error, and then eval do this automatically. But even if you do this, I don't think that C has the C compiler has any way to know what type something is, you know, under the hood. So even if you do this, I think it would be useless. Okay, what's the next question? How do you give an enum a name? Done. What are union data types and how do they work? Again, it's something that I don't have any knowledge from directly. I assume what union types are is a way to create new structures in C by combining primitive structures. Just a guess. What are union data types and how do they work? What are union data types in C and how do they work? So I assume that's the point. A union in C is a user-defined data that allows you to store different data types in the same memory location. So it's not. Yeah, I could have guessed that it has something to do with memory management. So store different data types in the same. Let's just zoom this a bit. In the same memory location. Store different data types in the same memory location. Unlike a struct where each member has its own memory, a union provides a way to work with different data types in the same memory space, but only one of the members can hold a value at any given time. Okay, somewhat confusing. Share memory, that's one key point. One active member, only one of the members of the union can contain a valid value. Writing to one member will override the value of the other members. Then why? How does this work? I don't want to jump to conclusions. The size of a union is at least as large as largest member. This is because the union must be able to hold any of its member. Union name, type. Okay, we have union names, the name of the union. These are the members. So I have a data. It has an integer. It has a float value. It has a character array. Here I created it. So data I is 10. I assume this will work. No, it actually doesn't work. Why? Why? Why are they used for? Output. Initialization and access. The union data has three members. It has I, it has F, and string. When you assign a value to data I, data F, or data string, that value is stored in the shared memory space of the union. Shared memory space of the union. Okay. Whatever. When you assign a new value to another member, the previous value is overwritten and only the new value. Use unions when you need to store different types of data in the same memory location, but only one at a time. So here's the key point. Same memory location. Same memory. Same. I think this is the key point. This is why the union could be useful. Again, I don't know a lot about memory management in C, so for me this just sounds stupid, but I assume it has a real reason. It has a background as to why we use it. It's a powerful tool for managing different types. Okay, when would we use union C? What are the use cases? Yeah. Okay, unions in C are a powerful feature that can be useful in several specific scenarios. They allow you to store different data types in the same memory location, with the caveat that only one of the types can be stored at the same time. When you need to store different types of data, but only one type will be used at a time. Only one type will be used at a time. But even if one type is used at a time, I think I'm putting too much pressure on unions behaving like classes in high-level programming languages, and that's why we might use a unions. Yeah, that's why I might misunderstand it. I mean, interesting. When you need to store different types of data, but only one type will be used at a time. In embedded systems or applications where memory is limited. Okay, where this changes. This changes. Oh, sorry, my back is a bit stiff. This changes the narrative of this a bit. So we have limited memory. Where memory is limited. Where can memory be limited? And why is memory limited? Unions can be used to save memory by allowing multiple variables to share. Okay. In this example, if you have a sensor that can either report temperature, pressure, or status, but never at... okay. Okay, I think this makes sense a bit. I worked with Arduino a bit, and I imagine this makes sense. I imagine this makes sense. Okay. Let me just stretch a bit my backs. It's hurting. Oh. So interpreting data in multiple ways. Yeah. Yeah, I mean, my confusion arose from the fact that I don't know a lot about C programming. And now reading through this, it makes sense. It makes sense that we need to interpret data in multiple ways, considering that there are no way to cast data easily and readily available in C. Variant data structure, accessing hardware. Yeah, there's a lot of cases in which we could use it. Okay, I'm fine. I understood it. Can you change how LL is defined to use union instead of struct? This is it. Interesting. how could I use a union here? I have a type, I have an error, and I have a numeric value here. Where do I use the numeric value? Eval if type num, it's here. How would I rewrite this? There's no way I could use a union to I could I could exchange the struct for the union because I know I need both the number and the type, right? Where's the type here? So I need the type and the error. So there's no way I could squeeze through with only one value existing for. Actually, I wrote to this guy. Let's see what he says. Can we change how LVAL is defined? Yes, we can change the LVAL to structure to use a union instead of having separate integer and long fields. This is useful when you want to store different types of data in the same memory location. Okay. Redefining LVAL with a union. So what we have LVAL. Yeah, as I said, so we create a union here because you can either have one or the other. The union name. So yeah, here's an example. I like how ChatGPT remembers what we wrote beforehand. Okay, I won't touch this. What are the advantages of using union instead of a struct? Better memory management. The only thing I remembered. Better memory management using the same memory space. I think I did this and I did this as well. So I can comfortably say I'm good. So let's continue. Let's continue with S expressions, lists and the Lisps. Lisp theory and practice. So there's a book here. Can I understand anything of what's written here? So we have a lambda function. What does this shit even means? Okay. Lisps are famous for having little distinction between data and code. They use the same structures to represent both. This allows them to do many powerful things which other languages cannot do. If we want this power for our programming language, we are going to have to separate out the process of reading in input, evaluating the input we have stored. So I like this part of the color circle. The reds give it a strength. So if you want, we need to separate the process of reading the input and evaluating the input we have stored. So what does this mean? Separate out the process of reading in. Okay. The final result of this chapter will only differ slightly behavior for okay, refactoring. A phrase I I'm well aware of. So my Moonreader Pro collapsed. I think I selected this and refactoring. To store the program, we will need to create an internal list structure that's built up recursively of number symbols and other lists. For the program, okay, we will need to create an internal structure that's built up recursively of numbers, symbols, and other lists. Okay, in Lisp, this structure is commonly called an X expression, standing for symbolic expression. This was probably really important. I still have no idea what it means, but I assume it's really, really important. We will extend our LVAL structure to be able to represent it. The evaluation behavior of our X expression is the behavior typical of Lisps. So S expressions. So what do we have here? In C, no concept of lists can be explored without dealing properly with pointers. Pointers are famously misunderstood aspect of C. They are difficult to teach because, well, I think that's the biggest problem when it comes to pointers. There is no clear use case. There is no way in which you can say, okay, this is an example in which a pointer is useful. This is an example in which we can drill in why you would use a pointer in this case. No, it's just, it's there and it works. This makes them appear far more monstrous than they are. Okay, so we have a couple of use case examples in the book. The reason we need pointers in C is because of how function calling works. Function calling works. Okay, when you call a function in C, the arguments are always passed by value. Let's say we have int a long b, and this is the function foo. I'm just I'm just freestyling it. So the arguments are always passed by value. This means a copy of them is passed to the function you call. A copy of them is passed to the function you call. So if I call somewhere foo in my code, and foo has A and B, a copy of them. So if I have in the memory, so this is, let's say, my memory, and I have, I don't know, a piece of memory here. This block is passed here, right? And for the long as well. I assume it works like this. A common problem occurs when you have a large struct containing many other substructs we wish to pass around. Okay, large structure containing many substructures. Every time we call a function, we must create another copy of it. Okay, this makes sense. This makes sense. So what, we have a huge object. Here's some data, and here's some more, and maybe another one. So if we have a huge object, I assume that this is a lot of data to be moved around. When we define a struct, it's always a fixed size. It has a limited number of fields, and each of these fields must be a struct. I mean, this whole paragraph makes sense. Struct is fixed. You know, if we want to fill up the struct, we need to fill it up. Not here, not here, not here, not here. We need to fill it up all the way. Okay. To get around these issues, the developers of C came up with a clever idea. They imagined computer memory as a single huge list of bytes. This must be the single best explanation of pointers I've heard. This paragraph. So basically it says there's a memory address. I don't know. Instead of passing this whole huge object that exists, we can just pass the memory address. Wow, nice. Nice, a really good explanation. by using addresses instead of actual data. So functions can also use pointers to do other stuff like output data to some address. Okay, okay. So I can get data to a memory address and from a memory address. I can store data, a pointer data here, or retrieve it. Okay. Because the total size of computer memory is fixed. Oh shit, just a second. No, what the fuck? Is my internet not working? No, it is. Oh, sorry. I have troubles with my ISP for some reason. Every day at around 8 or so, my internet just goes kaput. Thankfully, it's okay now. Okay. Because the total size of computer memory is fixed, the number of bytes is always the same. Wait. Because the total size of computer memory is fixed. What does this mean? Total size of computer memory is fixed. The number of bytes needed to represent an address. It's always the same. Okay. What does this mean? What does this mean? Sorry. What does this mean? Because the total size of computer memory is fixed. But if we bytes points to can grow and shrink. What does this mean in relation to C pointers? Ah, okay. Okay. I get it. Okay. Let's go back to the book. So a pointer is just a number. A number is representing the starting index of some data in memory. The type of pointer hints to us, and the compiler what type of data. To create a pointer to some data, we need to get this is what the ampersand means. It gets the address of some data. Okay, I'm a dumb idiot. Ooh, so a lot more information here. We also will learn about the stack and the heap. So sorry, I'm just this is a big chapter. Yeah, this is a huge chapter. Okay. Just a second. My back. My poor back. Oh, I'll just do another quick stretching session. Sorry. Okay, not gonna lie, it helped. It helped tremendously. So what are we doing now? We are learning about the stack and the heap. So I said that memory can be visualized as one long list of bytes. Actually, it's better to imagine it's split into two sections. I said that memory can be visualized as one long list of bytes. Okay, but it actually isn't. It's split into the stack and the heap. Dealing with the stack and the heap C can be complex, but it doesn't have to be a mystery. In essence, they are just two sections of memory used for different tasks. Okay, stack and heap, different forms of memory. Let's continue. The stack is the memory where your program lives. It's where all of your temporary variables. Local variables. We break local variables. Copies of any arguments passed to the function. Okay, so this is the stack. And the heap is a section of memory put aside for storage of objects with a longer lifespan. Using the heap is trickier than the stack because it requires the programmer to remember to call free and call it correctly. Okay, okay. Okay, we are now thinking in S expressions and not in Polish notation. We need to update our parser. Just a second. Okay, we need to update our parser. So we are not using the Polish notation anymore. We are using the S expressions. Okay. Let's see. Let's see what's done here. So is this Vim? It is. Okay, it's here. So what do we have? We have a number. This guy won't be an operator. This guy will be a symbol here as well. Oops. Here as well. How do I copy? I forgot. Is it C? PP? No. No. How do I copy shit? I forgot. How to copy a line in Vim. Only one line. Okay. Ah, yank. It's not copy, it's yank, and then I parse. Okay. So okay. And I insert. I'm gonna insert sexpr, the S expression, with an unfortunate way of naming it. Okay. We have S expression, we have expressions, and we have Lisp, which is our language that we created. So let me just redo this. We have a number. We have a number. We have a symbol. Symbol. What else will we have? This. So how does this work? We open a parenthesis. We can have an expression here. And we close the parentheses. Okay, so it can be a number or a symbol or an S expression. And the language is an expression. Number, I need to add a symbol here. Symbol, S expression, Lisp, and I need to clean it. 5 of those guys. Number, symbol, S expression, and Lisp. Okay. I have no idea how this now works. I'll just ask my companion, my friend. Please explain how this works. Break it down like I'm an idiot. Okay. Okay. let me just go through this and let's let's break this down. This code is part of a simple Lisp-like interpreter written in C using an MPC library, which is a library for building parsers. Okay. Creating a parser with a name, and I have 5 different pointers to parser objects. A parser for recognizing numbers, a parser for recognizing symbols. Okay, this, I want to see how the language is defined. Okay, this function takes grammar rules. This rule defines a number as a sequence of digits, possibly preceded by a minus. We have symbols. Okay. Okay, I was just thinking how this works. So what do we have here? We need a way to store S expressions as LL. This means we'll also need to store symbols and numbers. We are going to add two new LL types into the enum. The first is LL sim and LL S expression. Okay, let's move it above. Where is the enum? It's, I think, here. Yeah. LL symbol and LL S expression. Fucking god. S expressions are variable length lists of other values. I need to break this down. S expressions are lists, but unlike array. Okay. But unlike arrays in modern programming languages, they are not fixed in size. You can have S expressions with any number of elements, from 0 elements to many elements. This means an S expression can be very short, like this, or much longer, like this. Okay, so this is a more complex example. Oops, as we learned at the beginning of this chapter, we can't create variable length structs, of course, because they're memory fixed. So we are going to need to use a pointer. Okay, I get it. We are going to create a pointer field cell. So what's going on here? We're going to create a pointer field cell. So this is a pointer field. Just a second. Okay. We are going to create a pointer field. It's a field cell. It's called cell, which points to a location where we store a list of our field should therefore be a double pointer type, a pointer to elbow pointers. Okay, I also have no idea what this means, but ChatGPT was really helpful. We are going to create a pointer field cell which points to a location where we store a list of elbow. More specifically, pointers to the other individual elbow. Our field should therefore be a double pointer type elbow bum bum. A pointer to elbow pointers. What does this mean? Please explain it. A elbow is a pointer that points to a single elbow object. But this is a pointer that points to another pointer. Okay. Okay, I think I get it. I get it. Mm-hmm. Okay. So let's edit this. Let's change the structures. It said that we can remove the error. And how do I remove it? What's the... How to remove a line in Vim. How to remove, delete a line in Vim. DD. Okay. DD. Okay. So now here in type long num I can remove this. I can remove this. I can do this. I can create a pointer. I can create a pointer to this as well. I can create a count and I creating a pointer to a list of pointers of other lvals. Our new definition. Okay, so what I'll do is I'm gonna stop here. I'll continue this some other time. What I wanted to do now is I wanted to read a bit